Today, we're bringing distant exoplanets closer to home. How much closer? Well, we're moving them right into our solar system. We'll start with TRAPPIST-1e. TRAPPIST-1e is a terrestrial planet, just a little smaller than Earth. Back in its star system, 41 light years away, this world orbits extremely close to its star. But it's okay because that star is tiny. Yeah, TRAPPIST-1, that's the star, is smaller, redder, and way colder than our sun. It's classified as an ultra-cool dwarf star. Nice. The distance between TRAPPIST-1e and its star is only about 3% the distance between Earth and the Sun. And that's actually within the habitable zone of this tiny star, TRAPPIST-1. Now, when we were deciding where to move TRAPPIST-1e into our solar system, we thought placing it as close to the Sun as possible would be a great move. But not at the same distance as it orbits its own star now, because at 0.03 astronomical units, our sun would crisp this world up like a piece of burnt toast. No, we're going to find a cozy spot for TRAPPIST-1e in the orbit of Mercury. The orbit of Mercury is about 0.4 astronomical units from the Sun. That means that TRAPPIST-1e would be orbiting the Sun 13 times further away than it orbited its own star back in its star system. But the Sun is bigger and hotter than TRAPPIST-1, so even in this faraway orbit, TRAPPIST-1e would be getting a lot more sunlight. The surface temperature on this alien planet would jump to extreme levels too, and this heat wouldn't take long to hit TRAPPIST-1e. No, this planet would become scorching in a matter of days. And within years, well, whatever water might be contained on this planet would boil away. So if we're thinking in terms of habitability, that's bad news for TRAPPIST-1e. Habitability-wise, back in its own star system, TRAPPIST-1e is the most promising of all its TRAPPIST neighbors. Yeah, it has 6 rocky planetary neighbors. Some of those planets are boiling hot, too hot for any life to exist on them, and some are frozen worlds, but TRAPPIST-1e kind of rocks. It's right in the habitable zone. It's got an atmosphere, land, lakes, and oceans. It even has similar gravity to Earth's. TRAPPIST-1e is no doubt our best candidate for Earth 2.0. Or at least it was before we moved it into Mercury's orbit. Now, any hope we had to make this planet our home away from home would be gone. The cool thing is, in Mercury's orbit, you'd be able to see it from Earth. Yeah, it would be a dot in the sky, but a bigger and brighter dot than Mercury. Even without a telescope, it would appear as a bright star. Another piece of good news is that placing an exoplanet 2.4 times larger than Mercury in that orbit wouldn't cause significant gravitational damage to our solar system. It might nudge Venus slightly, but that would take thousands of years. So yeah, bad news for TRAPPIST-1e, but not so bad for you on Earth. Hey, now that this exoplanet is so close, you could finally land on it. Or really land on whatever was left of this once possibly habitable world. Now, to make things a little fairer for TRAPPIST-1e, we should place it closer to Earth's orbit, like in the asteroid belt. The asteroid belt is this region of space between Mars and Jupiter. It has millions of asteroids in it. But unlike in Star Wars: The Empire Strikes Back, these asteroids aren't closely packed together. The average distance between them is around 1 million kilometers, 600,000 miles. There's plenty of space for TRAPPIST-1e. But the asteroid belt is 2.5 times further from the Sun than Earth is. So in this position, TRAPPIST-1e would only get 16% of the sunlight that we get here on Earth. Once again, bad news for this exoplanet. It would quickly lose all its heat and turn into a frozen wasteland. All of its water would become locked into water ice. At this point, it would no longer be Earth 2.0, it would be a new Mars. If TRAPPIST-1e did have any hint of life, it would be obliterated. Unless that life was beneath the surface and could adapt to this sudden climate change. But here's where things get interesting for our solar system. A planet almost as large as Earth in the asteroid belt would not be good for you. Okay, at first it would be business as usual, but over millions of years, TRAPPIST-1e would yank asteroids out of their orbits. Its gravitational effect would grow, and millions of years later, it would start disturbing the orbits of Mars and Earth. Even worse, it might start affecting Jupiter's orbit. And when that giant of a planet shifts orbit, well, the entire solar system is in danger. Yeah, even a slight shift in Jupiter's orbit would affect all the inner planets. It might even send Mercury crashing into the sun. But that would take billions of years, so nothing to worry about for now. Okay, clearly TRAPPIST-1e would have no luck in either of these orbits, and placing it too close to Earth would be dangerous for our planet. So let's try moving another exoplanet, Kepler 442b, into one of our spare rooms. Kepler 442b is a heavyweight of rocky planets. It's 1.3 times the size of Earth and packs 2.3 times our planet's mass. It's like Earth on steroids, or as scientists call it, a super Earth. Now, one moment it's orbiting its cool orange dwarf star 1,200 light years away, minding its own business, and the next moment it's teleported to our solar system. But where do we put it? Well, back in its own star system, where Kepler 442b is the one and only rock, it happens to orbit its star's habitable zone. But that star, Kepler 442, is a K-type star, which is cooler and dimmer than our Sun, a G-type star. So 442's habitable zone is way closer. If we replaced our Sun with Kepler 442, that would place Mercury in the habitable zone, and Venus would be just outside of it. But we're not replacing the Sun here. We're just placing Kepler 442b at about 0.5 astronomical units from the Sun. Yeah, a bit closer to Mercury than to Venus. Now, that's no longer within the habitable zone of the Sun, and that means, well, things are about to get hot for Kepler 442b. However, what makes Kepler different from TRAPPIST-1e is that Kepler 442b has stronger gravity, so it would fight for its atmosphere. Yeah, we believe that Kepler 442b is a great candidate for a habitable world. It's bigger than Earth, so it would have a lot more surface to live on. But let's be honest, we're not going to travel 1,200 light years to settle there. And here, so close to the Sun, this planet isn't going to be a tropical destination. It would be hellishly hot. Its oceans would evaporate, but the atmosphere would stick around. And that's a bad thing, because instead of a super Earth, Kepler 442b would become a super Venus. Yeah, all that vapor from evaporating oceans would make its thick atmosphere even thicker. And in the same way that Venus traps its heat on the surface, Kepler 442b would do that too. Except that Kepler 442b is almost 3 times more massive than Venus. Its strong surface gravity would hold on to the thick atmosphere, and after years of intense solar heat, this atmosphere could grow even denser. And if greenhouse gases began to trap more heat, it might end up even worse than Venus. You definitely never want to land there. And eventually, you might not be able to land there, because having a brand new super Earth in the inner solar system would shake things up. It would start slowly, and at first, you wouldn't notice anything, but after a few thousand years, Kepler 442b's gravitational presence would push the orbits of Mercury, Venus, Earth, and Mars. After millions of years, Kepler 442b might even toss those planets out of their orbits and make them collide with each other. And as that orbital mashup is unfolding, things would be changing down on Earth too. With an unstable orbit, Earth would have an unstable climate. And if we were on a collision course with Mars or Venus or even Kepler 442b itself, well, that would be the end of our planet. But these events would take at least 1 million years. You wouldn't see any planetary collisions in your lifetime. So let's go bigger and move a planet 5.5 times more massive than Earth. Yeah, cue Ogle 2005 BLG 390LB. This exoplanet is incredibly cold and super far. Yeah, Ogle 2005 BLG 390LB, we'll call it Ogle for short, is 21,526 light years away. Ogle orbits its star at a distance of 2.6 astronomical units. If it were in our solar system, well, it would be sitting in the asteroid belt between Mars and Jupiter. Now, we don't even know what type of star this planet orbits because its star is just too faint and too far away. But it must be some kind of cool star because Ogle is a frozen world. It's colder than anything we have in our solar system. Yeah, Ogle's surface temperature is only 50 degrees Kelvin. That's minus 223 degrees Celsius, or minus 370 degrees Fahrenheit. It's cold. And because we discovered this planet through gravitational microlensing, we don't even know how big the planet is. You see, there's different ways of discovering planets. Telescopes like the Kepler Space Telescope discover planets through the transit method. They look at light blocked by an exoplanet passing in front of its star. Gravitational microlensing is different. It measures the tiny bending and magnification of light from a more distant star. That bending is caused by the gravity of a planet when its host star passes in front of it. So we don't technically see the planet, we just know it's there, gravitationally affecting the light from its star. And that means Ogle could be a super Earth, or it could be a mini Neptune. For the sake of this experiment, let's imagine Ogle as a big, frigid, rocky planet. Now, if we move this planet into our solar system, right in the asteroid belt, it would be a huge change for Ogle. The asteroid belt gets about 16% of the sunlight that Earth does, which is a lot compared to Ogle's original orbit. But it's still not enough, not at first. The surface would remain deeply frozen, but it would warm up to about minus 200 degrees Celsius. But the longer it's in our solar system and the more heat it gets from the sun, Ogle would slowly warm up. Its surface ice would partially sublimate, creating an atmosphere, or adding to its atmosphere if Ogle already has one. Still, it would be too cold for us to land on, so we'd likely just send probes and rovers to explore the surface of this cold planet. Keep in mind that this isn't a small, lightweight planet like TRAPPIST-1e. Ogle is massive, 5.5 times heavier than Earth. It could be extremely dense and have a strong gravitational pull. Within a few million years, it would cause the asteroid belt to fall apart. The asteroids would be ejected of their orbits and flung forward, spiraling toward the sun. And some of those asteroids would take detours near Mars and Earth. Our daily weather forecasts on Earth would be calling for bright sunshine, light solar winds, and a 70% chance of catastrophic asteroid collision. The asteroid belt has millions of asteroids, and at least 1 million of those are a minimum 1 kilometer in diameter. That's 0.6 of a mile. So things would get disastrous fast. Eventually, after tens of hundreds of millions of years, Ogle would destabilize Mars, and once Martian orbit shifted, Earth would be next. So if humanity somehow made it to tens of thousands of millions of years, a giant asteroid might just wipe us out, like the dinosaurs. But things would get much worse, much faster, if we placed an epic super Saturn in an orbit around the Sun. This is J1407b, and it's magnificent. It orbits a star 434 light years away from us, and it is truly massive. J1407b is 20 times more massive than Saturn, but its rings are 200 times wider than Saturn's. Yeah, if we placed this alien gas giant in the same orbit as Earth, its rings would reach Mercury. Back in its own star system, this super Saturn orbits 10 to 15 times further from its star than Earth does. So in our solar system, that would place it perfectly between Saturn and Uranus. Now, those giant rings would dominate the sky. They'd reflect so much sunlight that you could see them from Earth. Though in its new orbit between Saturn and Uranus, you'd need a telescope to see them properly. But let's not forget, this planet is massive. It would be tugging at Saturn and Uranus, slowly disrupting their orbits. Over millions of years, this gravitational dance would destabilize moons, shift rings, or even pull Uranus into a more elliptical path. Smaller, icy bodies in the Kuiper Belt would no longer be safe. J1407b's gravitational reach would act like a celestial broom, sweeping entire regions of debris clean or hurling them inward toward you on Earth. Yeah, expect a higher number of asteroid collisions. Now, let's say we wanted to explore this absolutely magnificent giant and its rings with a probe flyby. Well, that could be difficult. Those rings aren't just icy rocks. They're millions of chunks, some as large as mountains, orbiting J1407b at thousands of kilometers per hour. A direct impact would vaporize a spacecraft. Now, J1407b might have hundreds of moons. Some could be larger than Mercury. If they cross into Saturn or Uranus's orbit, they'd crash into those planets. They might even make Saturn and Uranus's own rings bigger and brighter. If J1407b nudged Jupiter even a little bit, the effects could eventually ripple inward toward Earth. Jupiter is the anchor of our planetary orbits. If J1407b disturbed it, it would throw off the entire balance of our inner solar system. Over hundreds of millions of years, those tiny changes would add up. Earth's orbit could wobble. Asteroids would be smashing into us. Mercury might even get flung into the sun. Yeah, it gets chaotic. Now, imagine one of these exoplanets replacing our moon. Yeah, that would be pure chaos. But that's a story for another What If.